Hello, this is Mr. Stansbury. I'm going to take you through some of the problems from the 7C assignment. Okay, number one here, for each of the following tables, calculate the value of xy for each point. Okay, so let's just do that for the first one here right off the bat. So that means 2 times 12, that's 24. 3 times 8, that's 24. 4 times 6 is 24. 6 times 4 is 24. Okay, so we did that. Hence, determine whether x and y are inversely proportional. Since the x times the y equals the same thing on each one, they are inversely proportional. Inversely proportional. Okay, and then if an inverse proportionality exists, determine the law connecting the variables and draw the graph of y against z. Okay, so that means we know that x times y equals 24, right? Because 2 times x times y is 24. X times y is 24. There's our law. If we want to graph it, what we got to do is we want to get y by itself. So we divide both sides by x, and we get y equals 24 over x. Okay. So that is our let's see, determine the law connecting the variables. So that would be our little law thing here, and then draw the graph of x against y. So at 2, we are at 12. So that's going to be a little off the graph there. That's all right. 2 is at 12. 3 is at 8. 4 is at 6. And then 6 is at 4. Okay, so it's going to look something like that. Okay, there's our graph. Okay, so for B, 1 times 20 is 20, 2 times 10 is 20, 4 times 6 is 24, 5 times 4 is 20. Hence, determine whether x and y are inversely proportional. Because of this 24 here, they are not inversely proportional because they all have to be equal the exact same number. And then if it exists, determine the law connecting the variables and draw the graph of y against x. It does not exist, so we do not have to determine the law or draw the graph. Okay? Number 4, suppose y is inversely proportional to x. Explain what happens to y if x is doubled. Okay, so if it's inversely proportional, we know that x times y equals some number here, right? Okay, so if x is doubled, so now we have 2 times x. If x is doubled, this number times this number equals some given number, and this is constant, right? Then that means to make up for this being twice as big, this has got to be half as big. So it'd have to be 2x times y over 2, right? Because then that's what's going to get rid of this 2 over here. So we'd have to take half of the y. So what happens when x is doubled? For a, y is halved. Okay, or divided by 2 is fine, I suppose. Okay, so for C, if x is multiplied by 9/5, so we have x times y equals some number, and again, that's a constant number. So x is multiplied by 9/5 x. To get rid of that, we would have to take y and divide it by 9/5. Or an easier way to look at that is y over 9/5 is the same thing. Take this, if you're dividing by a fraction, flip it and multiply, right? So we get y is going to be, multiplied by 5 over 9. Okay? So y is multiplied by 5/9. That's a multiply sign there. Okay? Okay. 7, when a constant force is applied to an object, the object's acceleration is inversely proportional to its mass. Okay? So we could write that as acceleration is directly proportional to the inverse of its mass. So inverse of the mass would be 1 over m. That's how you could write that. Okay. When force is applied to a 5 kilogram object, the resulting acceleration is 1.5 meters per second squared. Okay, so maybe we can draw ourselves a little table here. We know that, let's see, A and M. So we know that when the force is applied to a 5 kilogram object, that's the M. So when force is 5, the acceleration is 1.5. Okay. So now here's going to be kind of the key here. We know that we would want to multiply these two together. 5 times 1.5 is going to give us 7.5. So we know that these two numbers here have to multiply together to get 7.5, right? Okay, so find the acceleration which would result if the same force acted on a 2 kilogram object. So that is going to be a 2 here, right? So basically, one way you could look at this is you're saying, okay, I know a 2 times some number, A, has to equal 7.5. So I just simply could divide both sides by 2 and get that A is going to be 3.75 for that right there. Since that's our acceleration, it should be meters per second squared. So just a kind of a little side note here, ms to the negative second, we are used to seeing that as meters per second squared, because that s to the negative 2 just goes to the bottom, so it's meters per second squared. This is how you're going to see it written on in the rest of this textbook and also on the IB test, so it's important to get used to that notation there. Okay. So this was A. So then maybe we'll do part B over here. Find the mass of an object whose acceleration under the force is 10 meters per second squared. So we still have our M and our A. And we know that 5 and 1.5 is true. We know that that multiplies together to give 7.5. So now they're saying find the mass of the object, the M up here, whose acceleration under the force is 10 meters per second squared. Okay, so it's the same idea. We know that M times some number, well, M is the number, 10 times M has to equal 7.5, right? So we know that these two numbers together have to equal 7.5 because that's what the first set is, and it says that it's inversely proportional. So simply divide both sides by 10, and the mass in this case is going to have to be 0.75 kilograms. Okie dokie. Okay. All right, that's all we have for the 7C worked problems. If you have any questions on any of the rest of these or any of these problems here, please feel free to ask. Thanks.